Góðan dag, velkomin á fyrirlestur hjá opnu kerfum Fíllinn í herberginu og áskoranir í nútíma umhverfi. Og Håkan, if you can turn to the next slide, please.
Next slide.
Þannig að í dag þá ég heiti Samuel Jón Gunnarsson og frá opnu kerfum og fyrirlesturinn í dag Håkan Hagerud frá Red Hat. I'm going to switch over to English now.
That's great.
Yeah.
It was a little bit hard to follow when you talked.
Yeah. So basically, tell me a little bit about yourself, Håkan.
Yes, for sure.
Job-wise.
For sure. My name is Håkan Hagerud, and I work as a solution architect at Red Hat in the Nordics. And as a solution architect at Red Hat, you are also more or less considered a SME, as in a subject matter expert on, some of our products. So my focus is mainly on infrastructure and cloud technologies like OpenShift, which is one of the technologies we'll be talking about today for sure.
Yeah, nice to know. And we are involved in these technologies in Open Kerfi, and we are looking forward to hear your presentation. And you can basically just start when you want, Håkan.
Yes, for sure, no problem. So I will start out. And the presentation is fairly short, and then I think we will have, some discussion afterwards.
Yeah,
and,
right.
Some comments and possibly questions if you ask questions. Mm-hmm. Right. So let's get into this, and we'll start with just change and the changing role of IT. So there's a quote from an analyst from, this is 17 years ago, but for sure, at least for me, I was in the business at the time. And quote is, IT doesn't matter, which at the time was very correct, since we were using more or less the same kind of setup, the same kind of technologies, off-the-shelf software. So there was no differentiation in how you did IT. Everybody did it the same way. And then we moved forward a little bit in time to 5 years ago. Another analyst, this time from Forbes, every company is a technology company with we're really talking about the IT company. And a year later from the Harvard Business Review, another analyst comes and says, every company is now a software company.
Yeah.
So there is a big change for us as IT professionals going on. And really what it boils down to is this: how we turn ideas from ideas we have into apps that our end customers really love, and how to do this faster than your competitors do. Because it's all about speed and change, right?
Yeah. Maybe somebody remembers these. So there used to be, you got the hardware and the operating system, the middleware, and some application, the entire stack from one player, very, very strong players. These were multi-billion companies. Yeah.
Some of them are still around, but these players are taking over.
Yeah.
Change is coming, right? Most people recognize or even utilize some of these services.
Yeah.
So it's about change, and it's as Darwin says, it's really not the strongest or the most intelligent, but the one most responsive or adaptive to change that survive, right? Sorry. So if we then look at what's driving this really sort of shift towards cloud technology is at the base, it's the application architecture that is a changing, right? So we used to build them in the monolithic approach. This is my representation of this awesome online store. Here we go. The new cloud native way of doing this, you would, instead of having one single massive application, you would have quite a lot of smaller ones together, creating the same experience for your end users. And sorry, with this old approach, the monolithic approach, there are both problems and things you would have to consider. So let's say, for instance, your application becomes super successful. Everybody loves it. Everybody wants to get in there. You need to scale. You need to supply more of your application. So with the monolithic approach, you can scale up. But eventually you hit the limits of, the physical world. You can only get this much big data, this much big compute.
Yeah.
For sure, you most likely would have two of these in a redundant setup, but still, you can only scale up so much. With the cloud native approach and this cloud native architecture, you instead scale out. You spin more of these small instances to accommodate the incoming load. And this comes back to another aspect which happens to everybody. Problems, outage, when something goes bad. Again, if we look at the monolithic approach, for sure, again, you would have two, but still, if there is a problem, everything is down, or half of it is down. Whereas, again, in the cloud native approach, where you divide everything up into these microservices, as we call them, if one of them have a problem, all of the other ones are still there, available, serving requests, doing their thing. One small portion of the application is not responding. But with the tool behind to orchestrate these things, there will be a replacement spun up very, very quickly. We keep diving into this a little bit. So again, usually when you talk about a big online store application, it contains a lot of modules. So in this example, let's say we would like to introduce a change to the sales module because we need to introduce this function right now because our customers want it. So in the monolithic approach, for sure you can input the change in the code, but then when the code needs to be, if it is like Java, something you need to compile, in the compilation you have to pull in the entire code base. Everything needs to be pulled into the compilation, which takes a lot of time. You also need to run a lot of tests. And so let's say again we are introducing changes to the sales module, but you will still need to check tests for all the other modules, the product catalog, all of these things.
Yeah.
So again, what we are adding here is time. It takes a lot of time to go from a change to it actually reaches your customers. Whereas again, we look at the cloud native approach, where you have really small applications, small services, and also you have smaller teams taking care of this.
Yeah.
So instead of many different teams taking care of one code base, you have a small team taking care of their small code. And could be like 100 lines or 200 lines, 500 lines, enough for that, a person can actually look at it and understand the entirety, whereas the big monolithic approach may be millions of lines of code. No human can comprehend that much. Anyway, back to this. So it's very easy to then introduce version 2 of the same module, and right now it's just introduced, it's not in use. But then for sure you can use some kind of again, load balancer in front. This is actually built into the platform. So you can have what's called a green-blue deployment, where 90% of your users come to the old version, but you allow 10% to reach the new version.
Yeah.
You get some feedback. You get this, what we call the feedback loop.
Yeah.
So the developers all get very, very fast feedback from their end users, either by asking or analyzing user pattern, how they are using this new sales module. So this enables, fast iterative approach by having this fast feedback loop.
Yeah.
Right, and for sure, if this is a success, then you just let version 2 become the prevalent, and slowly version 1 will disappear.
Mm-hmm.
So, I mean, it's all been elephants right now.
Yeah. Exactly.
But the technology we are talking about here in this cloud native world is centered around containers. So a container is a way of, packaging up your application,
Mm-hmm.
and any supporting libraries or frameworks that this application depends on,
Mm-hmm.
into a small portable format, which you then, you package it up once, and then you can use this
Mm-hmm.
package to run it, on your choice of underlying infrastructure. This can be run in your data center on, any of these bare metal virtual private
Mm-hmm.
cloud stuff, or in the cloud, for sure.
Mm-hmm.
Sorry, I need to have a drink.
Yeah.
But yes, sorry. So back to this. So this technology, we have a lot of customer who has adopted this and
Mm-hmm.
are successful with this. And a good approach is to start out something smaller, but eventually you end up having a lot of these containers, a lot of these containerized applications.
Mm-hmm.
And this leads to a need for some kind of platform to manage containers at scale.
Yeah.
And so I work at Red Hat.
Yeah.
So our response and this is what we suggest is for sure our packaging of Kubernetes, which is our product is called Red Hat OpenShift.
Mm-hmm.
And Red Hat OpenShift is built on our Red Hat Enterprise Linux, gets that industry
Mm-hmm.
acknowledged security from the base operating system. For
Right.
sure, Kubernetes is there to orchestrate, work with the containers, make sure they are up, make sure this amount of containers are running, and adds features like horizontal pod autoscaler, for instance, which is what I referenced when there were more smaller elephants scaling up when the new crisis, right?
Yeah.
So Kubernetes is the orchestration engine of containers.
Yeah.
But Kubernetes can be a little bit challenging to configure and specifically keep in compliance. So we, Red Hat, in collaboration actually with Amazon and Google, Microsoft and others, we introduced the concept of operators, which is more or less just automation packaged up into a very easy consumable package. More or less push button to do things in Kubernetes.
Mm-hmm.
So I have a short video clip of what is operators.
Mm-hmm.
Can you fly that thing?
Not yet.
Operator.
Tank, I need a pilot program for a B-212 helicopter. Hurry. Let's go.
Yeah.
I mean, imagine that you push a button and all of a sudden you know how to fly a helicopter, right?
Yeah.
I mean, it's not really exactly the way operators work for sure, but the concept of this, you know, we need to be able to package up these really complex structures and you know, features that we want to do in some way of you know, making it easy for end users to consume. So I mean, yeah, actually I will get into this a little bit in detail after you know, parts of this.
Yeah.
Sorry. So again, OpenShift, it sort of tries to fulfill or satisfy the needs that comes from two sides. Usually we are talking about what, you know, most people in the industry call DevOps, where you combine, you know, the operation people. They usually want, you know, stability. They want to be able to have good logging so that they can react when things go wrong, you know, all of these things, stability, cost control. And then on the sort of other side of things, developers usually want to be able to have freedom to choose the best available framework or library for their application. So again, if we go back to this monolithic approach, everybody would be using the same language to code. For instance, as an example, everybody would use Java. Everybody would have to use the same frameworks for Java because it all gets packaged up into the same binary. Whereas with a sort of multi microservices approach, more developers get to choose. Okay, so we are working with front end. Okay, we want to use Node.js as our, you know, to our language and these libraries to support. And, you know, by then allowing them to package that up into a container that can be run on the sort of stable OpenShift platform, you satisfy both of these sort of needs that you have.
Yeah.
And for sure, there are other tools built in, like, you know, CI/CD dev tools. There's actually it's possible to run your own IDE, so integrated development environment from OpenShift, if you like. We have a service mesh, which is what we call the packaging of Istio, which is great for both of these sort of roles. Operations get great insights into how's the traffic flowing in this application. And developers get to not worry about how do we, you know, when stuff comes up, when do we know if it's available, discovery of services. And you have functions like, you know, this serverless, which it's a bit of a strange name for, you know, you're having an entire cluster. Lots and lots of instances to provide serverless features and functions. But I mean, the idea is great. It's like the Lambda functions of AWS. They are just using capacity when you're using them. Otherwise, they are spun down to zero.
Yeah, exactly.
And my last point here is really that Red Hat is, you know, in collaboration with a large ecosystem of ISVs. So both on OpenShift and for sure on Red Hat Enterprise Linux, we have a really large and thriving ecosystem of both small and large players providing software that is certified to run on both our Linux and for sure on OpenShift.
Nice.
So everybody loves it.
Yeah.
So really, this is, I mean, what we are saying here is, you know, choose a tool like OpenShift that can support your agile, new, modern way of working, because the tool that you select have to be able to support the new way of working that you would have to introduce to go the monolithic approach to, you know, this modern cloud native approach.
Nice.
Cool. No problems. I do have one last slide. This is more of a very salesy slide, but we do this with quite a few customers. So we have a concept of, we call it Open Innovation Lab, where we do a residency. So we bring our best people to sit down with the best people from the company and together work out, modern ways, new ways of working with our tooling as the base. So in this example, lead time went from 38 weeks to 7 weeks, which is, that is an awesome amount of time not spent on just waiting for things. Same with fixing prioritized bugs. These are factual, actual, real-time changes that happened during this residency that we did.
Okay.
So it's all about speed, about being able to put your new feature or fixed problem, something into the hands of your consumers faster. And by so being able to adopt to change.
Yeah, exactly. Okay.
Great.
So
that was the slides.
Yeah, this was quite interesting, and of course, we at umhverfi, we are quite familiar with the technology, and many of the viewers perhaps are not. And I have some questions that I would like to ask after seeing the slides, and for example, this is a kind of digital transformation, modernization kind of topic. So if you could elaborate a little bit on what would be the business value from moving from a monolithic approach to a microservices platform. You more or less outlined it in the slides, but if we could elaborate a little bit on that. For example, we could take the approach, for example, companies that are not have not yet begun these journeys. How should they start in a way?
Yeah, that's the golden. You want the golden or the silver bullet, whatever you call this.
I guess there is no silver bullet in this. This is always per customer case, I would presume. But
absolutely, but so again, I did very briefly mention this. We have a program where we do a residency called Open Innovation Lab, where we take our people who actually know very well how to work in this new agile way, and sit them together with people from the customer, and we have already decided before this starts, okay, so this is what we're going to try to achieve. We have this problem. For instance, it takes us half a year to get a new feature into our web. To take an example from this presentation. And then we actually, by practicing many of these agile practices that we publish on our, or I shouldn't say our, but we are the driving force behind this. There is a very nice page on the internet called the Open Practice Library. Maybe if I can maybe actually share it, if you don't mind. This Möbius loop, most people have seen. And if you haven't, then this is what it is really all about. It's about this feedback loop, creating this so that you, as a wanting to do this more modern, you just what you really want to know is, am I doing the right thing?
Yeah. Getting feedback.
Getting the feedback, and also, getting the feedback to the people who actually have the capacity to react to it.
Mm-hmm.
So this is where, when we talk about this, initially we talk about, for sure, it's the technology that is the enabler of this. But in practice, to actually be successful, you also have to adopt this, new modern ways of working.
Yeah.
And at the core of this is, values that we as Red Hat are very, very pro, which is collaboration and, inclusion. Let everybody be part of it, because if everybody in the team is actively taking part, the results are much better.
Yeah.
So a very big challenge is to actually allow decisions to be taken much closer to where, this feedback is coming in.
Yeah.
So this very much depend on the structure in the company.
Yeah.
So if you have a very hierarchical setup,
Mm-hmm.
then this cultural change that enables, developers and operations people to take these decisions because they get the feedback they know.
Mm-hmm.
That is possibly the biggest challenge to overcome, because you're more or less letting go of control.
Yeah.
in a sense, and trusting, you're extending trust to your teams.
Yeah.
That they actually take the right decisions. They know your vision. They know where you want to go.
Mm-hmm.
So a lot of stuff comes with this.
Yeah.
You want to have these sort of, another phrase that is very much in use is the autonomous teams.
Yeah, exactly.
Right. And autonomous teams just more or less means that, each team that takes care of their small service should also have the power to change it.
Yeah.
So that it reacts, to how the feedback coming in from users, either, regular feedback or by, again, analysis of user patterns, how they're using your stuff.
Yeah.
To allow that to happen.
Mm-hmm.
That is a big challenge.
Yeah, exactly. So this is basically a matter of doing some kind of acceleration, try to scope a specific project to onboard, in a sense, using agile technologies and doing an autonomous kind of approach where the team is able to control their destiny, so to speak, in delivering the product.
Absolutely.
Mm-hmm.
And another aspect of this, which is, again, I have this open practice library in front of me, and there is a lot of different practices here, like
exactly
the impact mapping, or even such a easy thing as a daily stand-up.
Mm-hmm.
But if you go through and look at these sort of practices that we are promoting here, there is a common thread here. Mm-hmm. And it's comes back to this togetherness,
mm-hmm.
Together we make things faster, better, and if everybody has, if everybody has a voice,
mm-hmm.
you get much better results. So, there are a gazillion of different technologies.
Exactly, and I guess this goes a little bit back to the open source collaboration model that is a kind of organic kind of a force in that sense. Yeah,
absolutely, and that's what we are. I mean, we're we are, I think, the largest, without a doubt, enterprise software company who really has this open source development model. I mean, that's the way everything is done.
Yeah.
So, I mean, OpenShift is part Kubernetes. I mean, we are the second largest contributor to Kubernetes after Google, for sure, who started the project.
Yeah.
But it's, I mean, and then if we go to the Linux side, it's the same. Yeah, for sure, Intel contributes most to the kernel, and then some others. But then for sure, we are one of the top contributors there as well. And that's the way we develop stuff in these communities. And we have really seen the strength from working together in this way, having the brightest people in the world.
Yeah.
Debating over, is this the right approach? Is that the right approach?
Exactly.
And it's not always straightforward. But
No.
At the end, the results you get are usually exceptional.
Yeah, exactly. I agree on that. Another thing, for example, are there any? There are always case of for example, when you are creating these kind of solutions in this new way of working. I'm thinking, there are probably a fine line in this, and I'm not sure if you can completely answer it, but for example, over-engineering or under-engineering in this sense, is it? It's probably possible. For example, if you take a monolithic application and you are trying to modernize it, you could probably over-engineer it, and then you would probably be stuck in the same problem as with the monolith, because you over-engineered it, that it's too complex, I guess. So are there any common pitfalls that you have seen in this area, so to speak, or is the platform or the common practices in this technology stack kind of helping you out in that sense?
Yeah, I mean, to be brutally honest, for sure, we have seen over the years. I mean, so OpenShift has been around for, I think it is 6 years. It's a long time at least. And as soon as Kubernetes came out, we put Kubernetes into OpenShift. So we've been doing this for a long time. And I mean, it's the promise of Kubernetes and OpenShift is resilience, scalability.
Yeah.
Everything just works. If something happens in the background, it's not a problem, because the system is built around making certain that stuff is running. If a pod goes down, it just gets restarted. There are nice, catch. When is it available? When is it ready? All of these things that you connect together. But it's the technology is the enabler. But technology doesn't solve your problem.
No, that is correct.
And but for sure, you need the technology to enable you to get into this sort of modern multi-service architecture.
Yeah.
But without actually adopting these more cultural changes that we did discuss earlier, you will not get the benefits of these massive time gains that I showed on the slide.
Yeah.
Because usually this comes down to control, right?
Yeah.
and
Exactly.
it is a very, very big shift from the very controlled way of planning stuff, this waterfall method that most projects use. And you have control points and you have checks and balances and all of these things. You can still have them in the agile world, but you really want this enablement of the smaller team to move forward when they can. And when they have good information about this change is good, this change is bad, this bug needs to be fixed, to actually allow them to do it. That's so. This is where we see the major challenges. Actually, it's again, technology can be quite easy. Even though, I mean, if you look into Kubernetes, it's a very, very complex piece of software, without a doubt. But still, you can understand this technology. You can, So it's wrong to say it's easy, but you can understand.
So it's more. So it's maybe more about people and processes, in a sense.
It is, without a doubt. Yes, for sure. And we have some of the like real passionate advocates for agile and these ways of working who actually are participants in this open
practice library.
No, for sure. Their processes or their methods goes into this, but our services people who are part of this. I dropped the name now.
Or perhaps thinking about the innovation labs, or
yes, absolutely. I'm thinking about the innovation labs, and they sometimes describe this as the agile theater. So I mean, if you look in advertisements for developers, they all the hiring company all claim we're doing agile, but really they are not releasing the full control, and by not that they're not getting the time gains and the time to market that they want to. And then so what is the problem? It's the technology. Because the promise was, if you buy our technology, you will gain, what was it, 20%, 20 times cost. It is true, but you have to change the way you approach your development of software. How you reach your customers, because if you don't change that, no technology
will change it.
Will actually help you.
Okay. You also mentioned operators with a cool Matrix reference. Where you called the operator and he just dialed up some technologies that you could suddenly use. And
that you can suddenly use, and you have no clue of what was this, but now I know where it is.
Exactly. And there are some in these technology platforms we are using YAML, and there are other tools such as Helm, and then there is operators. And can you elaborate a little bit on this?
Absolutely, and for sure. I mean, if you have dabbled in OpenShift or Kubernetes, because I mean OpenShift is a Kubernetes packaging from us, then the only thing that you have to master in order to deploy stuff and change stuff in Kubernetes is YAML. So YAML is a structured way of writing instructions, more or less similar in concept to XML. So when you deploy stuff on Kubernetes or on OpenShift, what you are actually producing is a long long description of look like this. These are the rules. Get your image from here. Run it in these many copies. If it hits this much CPU, spin more. So it's a rule book.
Basically, an infrastructure as a code kind of approach.
Definitely. I mean, it's the essence of this. So Kubernetes can be seen as a complete infrastructure, and you build your infrastructure within. But so let's take an example of a fairly complex business intelligence applications, for instance. This I used to work for this company. And I think at the last count, we had, I think it was 46 different containers, services, as in microservices, making up the entire application. So all of these 46 microservices, each and one of them needs to be defined in this YAML format. How should you look? How many things, what are your, all of these, that you define.
Yeah.
It becomes very cumbersome.
Yeah.
I mean, 46 of them is so much YAML. So that's where Helm came in a few years back. So Helm is more or less a templating engine of YAML files. So you input one YAML file into Helm, and Helm outputs shitloads of YAML files for you. Which is great.
Yeah.
So you don't have to write them. So, but it's just really, in all honesty, it's just a templating engine. It's great. It's really good because you define all of these services in one Helm chart, and then you run it through the Helm binary or however that is done nowadays, and out comes all of these spec files. Spec files is the YAML files, which specifies how things should look, and it deploys onto Kubernetes. But then, since, you can sort of say that Kubernetes is a micro infrastructure for your entire application. Very similar in concept to a data center, to be honest.
Yeah.
You can have anything in there. You have firewalls and all of these things. And then all of a sudden we realized, or people realized, we don't only need to be able to deploy stuff or upgrade stuff. We also need to be able to run backups. We also need to be able to run restore of data, all of these things that you do in the traditional data center. We need to be able to do this in Kubernetes.
Yeah.
So our response, and again, we did this in collaboration with Amazon, Microsoft, and some others, was the concept of operators. So an operator is really, it's a container which contains some kind of automation for the specific use case. But so really what we are doing, what an operator is just all the logics of deploying, maintaining, upgrading, possibly running backups, all of these things. You put together all the knowledge of the company who develops the software into the operator, which takes care of your software. So it's another step on the way to not having to write all this YAML. So the operator creates all of these for us. The operator is where we put our knowledge of how to update, how to run backups, all of these things that we need to do within a more complex application.
Yeah. So
we for sure, sorry Samuel, I just want to finish. We for sure utilize operators in the platform. So for instance, OpenShift has a very nice feature, the OpenShift 4, which is the latest version, where you have a single button that you can push if you want to update the entire cluster. Yeah. So that will update all the underlying infrastructure nodes that you're running, all the containers and pods needed to make up all the services that is Kubernetes. Everything is updated by one push, right? Yeah. And this is then handled by a multitude of operators who knows very well one part of this that needs to be done. It's a nice concept.
Yeah. I totally agree with you on that. At least for the one push button upgrade for the cluster, it's quite nice to being able to just push it and wait a little bit for in an hour or so for a small cluster to be able to finalize the upgrade.
Yeah. And I mean, this actually solves one of the problems which has been prevalent in the Kubernetes community, and that is, how do we upgrade? Yeah. Because building Kubernetes on your own, you can for sure do it, and it's a very, very good exercise to get to know the technology. Yeah. But to run updates on your own is very, very, very challenging.
Yeah. There can be some problems with locking down the right version of the underlying operating system, so you don't break anything, And there are
Exactly.
a lot of challenges. I have been there.
Yes, I think most people who have dabbled with this
Yeah,
have been
yeah.
there. And then when we go out and say we, and in this we context, I say Red Hat, yes, we have a push button upgrade. People go, no, you don't.
Yeah.
It's never going to work.
Yeah.
But it actually works very
Yeah.
well.
Yeah.
And we have a lot of customers around the globe who is running updates to their, to their infrastructure, which provides one of their most important applications, or many of their most important applications, banks, for instance, or where you do your banking on your phone. This application is backed by Kubernetes, and in many cases that is OpenShift. And they are so confident with this that they are running updates to their cluster during the day.
Yeah.
People are using.
Yeah.
So, I mean, this enables the operation side of teams to work regular hours.
Yeah.
They don't have to be there Sunday night between 2 and 4, because that's when you have the lowest amount of people utilizing your service.
Yeah. Exactly.
They do it during the day.
Yeah.
And so yes, it is actually a very nice thing.
Yeah, it's always nice to be able to update on daytime. It's a privilege.
It is. And in all honesty, I mean, most of us have been there.
Yeah.
At 2 o'clock at night when things go wrong, because they always do, right?
Yeah.
And then, oh no, we have this problem with this network switch somewhere, but I don't have access. Do you have access?
Yeah.
No,
Exactly.
no, that's Jana. We need to phone her up.
Yeah,
By the way, do you have a number? No, she's asleep. Okay, let's wake her up.
Yeah.
And when you get woken up at 2 o'clock in the morning, you are not your most clever person.
Yeah. It takes time to wake up.
Yeah.
Most definitely.
Yeah. Absolutely.
And maybe the final question now is, for example, let's say you have now deep dived into the containerized world, and you have a lot of clusters, and one in each public cloud, and then you have some on-prem and some in a private cloud with a hosting provider. This has been a challenge, or at least for many, to be able to contain this in some manner. Are there any solutions around that for OpenShift platform, for example?
Absolutely, and this is something we again see in many of our customers who really adopt this new way of working. They do the cultural change. They really go all in. They bring all their teams on, and they have great success with faster times, new features to the market. And what usually happens is that all of a sudden there is need for more clusters, because we need another cluster for development. Oh, we need another cluster to develop that stuff. We don't want to break this one. Or this team needs another cluster somewhere. And so many of our customers have this.
Yeah.
Lots of clusters everywhere, and they are very easy to get.
Yeah.
I'm sure you can provide OpenShift very quickly to your customers, or they can go to any of these cloud providers like Amazon, Azure, and get OpenShift or some other Kubernetes from them very, very quickly to start stuff into. But and this actually goes very well right now. So like a few days ago or a few weeks ago, was it a week, something like this, there was a massive vulnerability in the sudo package.
Yeah, I know about that.
Most people know about this who make stuff, and these things happen. So you need to have some kind of control of your clusters.
Yeah.
You want them to, for instance, you want them all to connect to the same identity management solution, for instance, so that if I need to help you, I can still use my identity to connect to your cluster. That is one of the things that becomes a real problem if you spin up stuff everywhere and you don't connect it to this old idea of central IT, which is still valid, right?
Yeah.
And then you have the compliance demands, so they need to have compliance with NIST or PCI DSS, so all of these things, right? So how do we do this? Do we do this manually? For sure you can. We everybody knows this, right? So a year and a half ago, we were bought by IBM.
Yeah.
So we are part of the IBM family, even though we are still Red Hat and our autonomy. We get to do stuff the way we've always done, and so we are not being pushed in the IBM direction. When we were bought, we also exchanged a few products. So we used to have a product called CloudForms, which was an idea of a way of managing many hypervisors, also public clouds from the same interface. And this product was better suited for IBM. It fitted well into their their suite of hardware that they still sell. So we got from them a product which was built to help this problem with many Kubernetes clusters. And we took this, as we did with, we've also acquired quite a lot of software houses over the years, like Ansible, for instance. So what we always do is we take this in and then we open source it and then make it into an open source product. So this, but the product we have is called Red Hat Advanced Cluster Management, and that's exactly what it is. What it does is what you ask. So you get a central point where you can even have a sort of a self-service idea of, okay, so now I need a cluster. Okay, maybe it needs to run in Azure because that's where we have our other stuff. Okay, so you push a button and the cluster gets deployed in Azure. But there's also the component of policies built into this. So you can then set up rules to what I said earlier. You can set up rules that the clusters that are provisioned, they should have this connection to our central identity management, so you can use same account that you have there that you use there, or these kind of compliance demands. So it needs to be in compliance with NITs or NIFT or FIPS or whatever is your demand, right?
Different policies and providing governance over the clusters.
Definitely. Yeah. And also, there is a third aspect to this, is the observability across clusters. OpenShift and Kubernetes has really great tooling to look at one cluster at a time. If you run many, it's great to have this sort of single pane of glass where you can actually look into all of your clusters and you get to see all of your applications. And you can search across all of your connected clusters to show me, for instance, all the pods that are in failing state, or all the all the claims for storage that are not fulfilled. All of these things you can look at from the one pane of glass. So it's and for sure there are other tools available that do similar things, but this is our product to solve this for sure. But because there is a real challenge.
Exactly.
With the adoption comes many clusters. How do you manage this? How do we get this under kind of control?
I guess this is somewhat kind of, as the technology evolves and more people tend to use it, new challenges arise, obviously. So it's a typical evolutionary problem, in a sense.
It is definitely, and I mean it's sort of these self-autonomous teams that we have talked about, it enables speed and agility, and you can move really fast.
Yeah.
What also does is that usually, especially in larger enterprises, it creates what some people call shadow IT, right? Yeah. And but somebody has to pay for this, so there's a cost associated with running stuff in the cloud, for instance, and or building your own system to do whatever it is that you need to solve your problems right now. So there, you can see it as a pendulum motion, right? So the pendulum hits over towards the freedom and speed and enablement, and let's move really fast. But sort of when it sort of hits back, you get back to the idea of but there is not. Maybe there is something to this idea of having central control of stuff. And how do you sort of
balance these two?
How do you balance these two, right? That is
exactly
interesting. I mean, it's very interesting times to follow, because we're sort of moving back into the little bit more of yes, it's great. We need speed, we need agility, but if we lose all kind of control. That's not really good. So how do we support them with these teams with what they want, but still retain some kind of control?
The governance point is just shifting a little bit. Okay, I think we will have to wrap this up now. I would like to thank you, Håkon, very much for the presentation and the talk. It was enjoyable, and
it was fun. And hope everybody, everybody or somebody got something out of this.
And to the viewers, I would like to say that if you have any questions, please feel free to contact me. It's samuel@ok.is regarding these technologies, and if you have any interesting ideas around these technologies, please give me a email with your thoughts. So I would like to thank everyone for joining in, and maybe see you in the future.
Thank you.
Okay, bye bye.